Okay, now we move to question 1. Right, a tennis player hits the ball as traveling towards her 10 meter per second horizontally. Immediately after she hits it, the ball is traveling away from the 20 meter per second horizontally. So the mass of the ball is 0.06. Okay, what force does the tennis player apply to the ball? Okay, so question is asking you to calculate the force that apply on the ball, but you can't tell unless you know how long the impact lasts, and there will be different from one shot to another shot. So means if you know that when you hit on the ball, the tennis, how long the force that apply on the tennis, okay, you may able to find the force, okay, by using the velocity that given, okay, but in this situation we may able to calculate the impulse, right? Because the impulse is divided by ft, and is equal to mv minus mu, right? So for this scenario, you may calculate the impulse or force, okay, is equal to mv minus mu, and this is equal to ft. Okay, if you want to know the force, unless you know the t, if not you're not able to get the f directly, but you can get the impulse by this way. So you have a 0.06. Okay, initial is 20, sorry, the final is 20, and minus 0.06, different direction, right? We assume when come to a different direction and go out, it will be the positive. So by this way you may get the impulse is equal to 1.8 Newton per second, right? Okay, so for this question you can't solve to get the force, right, unless you know the time that apply the force on the tennis, right? So that if you know, you can solve for this question. Okay, let's say if you say the impact lasts for 0.1 second or 0.015 second, then you can calculate the different force that apply on the tennis itself. Okay, so this one for question 1. Okay, now we proceed to question 2. For question 2, a ball of mass 50 gram hits the ground with a speed of 4 meter per second and repulse at initial speed of 3 meter per second. The situation is modeled by assuming that the ball is in contact with the ground for 0.01 second, and during this time the reaction force on it is constant. Okay, so part 1, find the average force exact on the ball by the ground. Okay, so you know that the impulse that you have is equal to mv minus mu. Okay, and the m that given is 50 grams, 0.0 kg. Okay, multiply initial 3 4. Okay, hits the curve with a speed of 4. Okay, so we go up is a positive, and minus 0.05, negative 4. Okay, go in negative. Okay, so your impulse will be equal to 0.35. Okay, on the ball itself. Okay, impulse. And in this situation, you know that impulse is equal to ft. So 0.35 is equal to ft. And from here, you know that t equals 0.01, so f is equal to 35. Okay, so f is equal to 35. So that you can conclude that the ground exact an average upward force on the of 35 on the ball. So when the ball hit on the ground, okay, the ground will give another force to the ball. So Newton's third law. So in the upper direction. So we assume that upper direction is a positive. Okay, for part 1. Question 2. Okay, for question 2, part 2. Okay, find the loss in kinetic energy during the impact. Okay, so the initial, the KE1, okay, KE1 that we have is 1 over 2 mv square, 4 square. Okay, and KE2 after impact, we will have 1 over 2 times 0.05 multiplied 3 square. Okay, so by simplify these two, you may get the difference of change in the KE, right, will be equal to 0.4 minus 0.225. Okay, so you will get loss in the KE is about 0.175, right, 0.175 joule. So this kind of loss in the energy most probably will convert to heat when you hit on, current the heat, or when heat of the uh, when you have a collision, maybe you can convert to the sound, okay, when you hit on the wall. So okay, so this is loss of, because of loss of KE lah. Okay, so this one for part 2. Part 3. Which of the answer in part 1 and 2 would affect by changing in the modeling assumption that the only in contact with the ground is for 0.01 second? Okay, so if you refer to part 1, right, the impulse is equal to Ft. Right, so for part 1, yes, okay, will change. For part 2, we just care about the velocity. Okay, just care about velocity. So for part 2, not change. Right, the answer will still same. Right, so the changing only for part 1 and part 2 remain constant. Remain the same answer. Yeah. So this example will show that the important point that the mechanical energy is not conserved during an impact. There are some losses of energy. Although the force of gravity act during the impact is impulse negligible at such a short time. So the key point is conservation of mechanical energy is not conserved, right? So this is for question 2.